Hello, hi students. Welcome to this class. Today's class, we have the engineering drawing class. Today we are going to discuss, we are going to draw the projections of solids, one in which the prisms and cylinders we are going to draw in different positions. This topic is under the unit 1. Okay. What is mean by a solids? What are the different types of prisms? What is mean by a regular solids? We are going to draw the regular solids. Okay. In this projections of solids, we have these are the solids, regular solids. We know that this is the cube, which having 6 faces, sphere, hemisphere. Half of the sphere is called the hemisphere. This is a cylinder having the 2 bases and curved surface. This is the octahedron having the 8 faces, 8 triangular faces, and a cone which having 1 base and 1 apex. This point is called the apex. These are the pyramids. These 4 figures are called the pyramids, and these 4 figures are called the prisms. Prism means prism and pyramid. You should know first of all what is a prism, what is a pyramid. In the projection of solids 1, we are going to draw the projections of prisms, and in the projection of solids 2, we are going to draw the projections of pyramids in different positions. These are the 3D diagrams. This is the triangular pyramid. Triangular means the base. A pyramid having 1 base at the bottom and 1 apex point. This is the point, apex point. This apex point is joined with the base by the slant edges. These are called the slant edges. 4 slant edges, in which 3 are visible slant edges and 1 is invisible slant edges, which is located as a dotted line here. And the base is also having the 2 sides are visible base, a rectangular base, and another 2 sides are invisible, because these 2 sides are back side of the diagram, back side of the solid, therefore which is located with the dotted lines. These 2 lines are dotted, and this slant edge is also dotted because these 3 lines are invisible when looking from the front side of the solid. This is called the rectangular pyramid. What pyramid means? It's having the 1 base and 1 apex point. That apex point is connected to the base corners with the slant edges. This is the slant edge. This is the slant face. This is the triangular face, and this is the base. This is the terminology which are going to use. This is called the base, rectangular base. That rectangular base connected to the apex point with the slant faces. These are called the faces. This is called the base. Okay. This is the hexagonal pyramid. Hexagonal means the base having 6 sides, that 6 corners, and the 6 corners which will be connected to the apex point. This is the apex point with the slant edges. This is the slant edges and slant faces. 6 slant faces. The hexagonal pyramid having 6 slant faces and 6 slant edges. A rectangular pyramid having 4 slant faces and 4 slant edges, 1 base. Triangular pyramid having 1 triangular base. This is triangular base, where the triangular base corners will be connected to the apex point. It's having 3 slant faces, and 3 edges, base edges, and 3 slant edges. These are the base edges. This is the slant edges. Okay. This is the pentagonal pyramid having the 5 sides of the base, that 5 corners and 5 sides. The 5 corners will be connected to the apex point with the slant edges, which form the slant faces. Okay. This is the prism. These are the prisms. What is the difference between the pyramid and prisms? Pyramid having only 1 base, and 1 apex point. But a prism means having the 2 bases, bottom base and top base. Those 2 bases are connected with a straight edges. These are the straight edges and straight faces. This is the hexagonal pyramid. Prism, hexagonal prism having the 2 hexagonal bases and those two hexagonal base corners are connected with each other with with a straight edges. These straight edges are 6 and straight faces, rectangular faces are 6. Here the slant faces are triangular in every pyramid, but in prism the straight faces are rectangular. Okay, hexagonal prism having, it is classified based on their bases. This is the triangular prism having the two triangular bases are connected with the straight edges, 3 straight edges which form the straight rectangular faces on 3 sides. This is the one face. Another face is on the right side, that is the back side of the prism, and also second one, the third one is this side of the prism. Totally 3 straight rectangular faces. Okay, this is the pentagonal prism. Pentagonal prism having two pentagonal bases which are connected with the straight edges which forms the straight rectangular faces. The pentagonal prism having two bases, 5 straight edges and 5 straight rectangular faces. Okay, this is the quadrilateral prism, that is a quadrangular prism, that means a square prism. Square prism is called square prism having two square bases on the top and bottom side. Those two square bases are connected with a straight edges, 4 straight edges, which are, out of which 4 straight edges, 3 are visible lines and 1 is invisible line, that is located with drawn with the dotted line. This is the 4 straight edges and which form the 4 straight rectangular faces. These are called the faces. Okay, out of this, the 4 faces, we are visible faces are 2 only, another 2 faces are invisible in this case. Okay, these are called the prisms. These are called the pyramids. So cone is under the pyramid because cone having only one base and one apex. Cylinder is under the prism because cylinder having 2 bases. Clear? These are called the solids of revolution. Cone, sphere, and cylinders are called solids of revolution. Let us go for the classification of solids. Classification of solids are classified into 2 groups, broadly classified into 2 groups. It's the polyhedron and solids of revolution. Polyhedron means which having number of faces. Polyhedron are subclassified into 3 types. Polyhedron are classified into 3 subgroups. A solid which is bounded by plane surfaces or faces. These are the faces. Here, green color. This is the pink color. These are called the faces, are called the polyhedron, which meet in straight lines called edges. These are called the edges, slant edges. This having the slant edge. This is having straight edge. This is also having slant edges. Okay, polyhedron are classified into 3 subgroups. 3 subgroups. In that, first one is regular polyhedron. A regular polyhedron having the number of equal sizes faces. Okay, this cube having, this is called the cube or hexahedron, which having 6 equal faces, equal size faces. This is the tetrahedron. Tetrahedron having the how many faces? 1, 2, 3, and 4 faces. 4 faces, equal size faces, are called the tetrahedron. This is having 8 equal size faces, called the octahedron. Octa means 8, hexa means 6, tetra means 4. Okay, these are the regular polyhedron, which are called regular polyhedron. The regular plane surfaces having same areas. These are the same areas. Areas are called the faces. These are called the faces, and the lines connected adjacent faces are called edges. These are called the edges. Okay. Example: tetrahedron, hexahedron, and octahedron. These are the diagrams. Okay. This is one type of solids. And second type of solid is prisms. As earlier I explained, these are the prisms. A prism having 2 equal and similar end faces or bases are called the top face and the bottom face, which are also called bases. Okay, joined by the other rectangular faces. Clear? Let us take this is the triangular prism. Triangular prism means which having the triangle on one side and also another triangle on another side. These two triangles are connected by two straight edges, three straight edges, which form the three straight rectangular faces. This yellow color is face. This is the orange color is base. These black colors are straight edges, and these black colors are base edges. These are the base edges, these are the face edges. Okay, this is the square prism. Square prism having the two squares connected by four straight edges from the four corners. And these green colors are called faces, and this green color is represented as base. Another base on other side of the prism. This is the rectangular prism having the two rectangles on both sides, which are connected by four straight edges and which forms the rectangular faces on four sides. Okay, this is the pentagonal prism. Overall, the prism is represented that prism having two bases, equal size bases connected by straight edges, which forms the straight faces. If this is pentagonal prism, two pentagonal equal size pentagons on two sides, those two pentagonal shapes or corners are joined with the straight edges. Corners are joined with the straight edges, which form straight faces, rectangular faces. Okay, so pentagonal prism having five base edges and five face edges. These are called the face edges. These are called the base edges. Hexagonal prism having the 6 base edges, 6 face edges. Octagonal prism having the 8 base edges and 8 face edges. Okay. Third type of solids are called pyramids. A pyramid has a plane figure as at its base and an isosceles triangle faces that meet at a common point. It is the plane figure. This is the plane figure. Base is the plane figure as at its base. Base having the plane figure and an isosceles triangle faces that meet at a common point called vertex or apex. This common point daggara and meet outu untai edges. That common point is called vertex or apex. The line joining the apex and the corners of its base are called slant edges. These are called the slant edges. This is the slant edge. This is the slant edge. What it is called triangular pyramid, because triangle is the base which connects the base corners are connected to the apex point. This is the square pyramid. Square is the base. The corners of the squares are connected to the apex points. This is the rectangular pyramid. This is the pentagonal pyramid having the pentagonal side, pentagon at the base. The pentagonal corners are connected to a common point, vertex or apex, with 5 slant edges. Like that, hexagonal pyramid and octagonal pyramid. These are the pyramids. These are called the prisms. Okay. Second type of solid is solids of revolution. These are all under first type of solids. This is the second type of solid is solids of revolution. That means if a plane surface is revolved about one of its edges, the solid generated is called the solid of revolution. Example, if a rectangle is plane figure, if the rectangle will rotate about this one of its edges, one of its straight edges, if it is rotate circularly, it forms a circle on the top side and also forms circle at the bottom side. If we join these two, it forms a cylinder. So revolution of the rectangle about its edge, which forms the cylinder. Like that, revolution of a triangular. So one triangle is there, a right angle triangle like this. If we rotate this right angle triangle about this perpendicular line, this is the straight line, straight edge. If it is rotates, it forms like this 3D diagram. It's a base forms a circular base like this. Okay, like that. A plane figure rotates about its straight edge, then these solids or forms. Okay, if the circle is rotated about its center, the sphere will be forms. Okay, these are the solids of revolution. The solids which forms the revolution of a flame figure is called the solids of revolution: cylinder, cone, and sphere. These are about cylinders. These are about solids. Okay. These are the plane figures located. Prism. These are all prisms. Prism, as already I explained, that prism having two bases. It is a triangular bases are there. These two triangular bases are connected with straight edges. Corner of the bases are connected with three straight edges, which forms a rectangular straight faces. These are the faces. This thin line is called the axis. This is the axis. This is the face. This is the bottom face. This is the top face. Top face, bottom faces are called bases. Okay. And longer edge. This is the longer edge. This is the base edges. Okay. This is a square prism having the bottom face or base, top face, longer edge. These are the longer edges, four longer edges, and one axis, and one four faces, straight faces. This is a rectangular prism having two rectangular bases. These prisms are named based on their base shape. Bases shaped batti aa prisms ni manam represent chestam. This is the rectangular base. This is the rectangular base, because that's why we are calling this rectangular prism. So pentagonal prism having two pentagonal bases which are connected, the corners of the pentagonal connected with the straight edges. Okay, hexagonal prism having two hexagonal shape bases which are the corners of that bases are connected with straight edges. And cylinder which are having two bases having circular shape which are connected with the generators. These are called the generators or straight edges. This is the axis. This is the base. These are all prisms. These are all called prisms. So prism means prism having two bases which are the corners of the bases are connected with straight edges. Okay. Coming to the pyramids, these are all under pyramids. Pyramid means which having only one base. Clear? Pyramid having only one base and one apex point. This apex point is connected to the corners of the base called the slant edges. These are the slant edges. Triangular faces. These three are called triangular faces. Two are visible here. Third one is back side of the diagram. Okay. Bottom base, bottom face or base. This is the apex point or vertex point. This is a square pyramid. Base having the square in shape, and that base corners are connected to a common point apex with the slant edges. This is called the square pyramid. Rectangular pyramid, pentagonal pyramid having the pentagonal shape of base, which are corners of the base is connected to the apex point by slant edges. Like that, hexagonal pyramid having the base, hexagonal base and 6 slant edges. Cone having the circular base which are connected with apex with the generators, slant edges. That is not edges. These are called the generators. Cone having the generator, cylinder having the generator. Remaining pyramids having the edges, slant edges, which are called slant edges. Okay. These are all about this total topic is about pyramids. What are the different types of solids? Now, solid position. We are going to draw the solid position in different positions are there. About 6 types of positions here. The following positions of solids in space. Okay, solid space lo a position lo untundi anedi. Based on the solid position, we have to draw the front view of solid and top view of solid. The front view is projected onto the vertical plane. Top view is projected onto the horizontal plane. The top view is must be below the XY line and front view is above the XY line. Okay. So these are the 6 positions. The axis of the solids parallel to VP and perpendicular to HP. This is the one of the position. Whenever the solid axis is placed parallel to the VP, this is position parallel to the VP and perpendicular to the HP. Horizontal plane ki perpendicular ga untundi. Vertical plane ki matram ee axis parallel ga untundi. Like that, position of solid is like this. Okay. Whenever the solid position is like this, we should draw the top view first, because the circle is visible from the top side. So first to draw the circle onto the which is projected onto the HP, which is below the XY line. So draw the circle first here, plane of paper. On the plane of paper, first draw the circle having the diameter equal to the cylinder base diameter. and the points on the circle are projected towards the above XY line, because the front view of the cylinder, when we look from this side, the front view of cylinder looks like a rectangle. This is the green color. Green color is the rectangle. So this is a rectangle which looks like a rectangle, and top view is a circle. Okay, this is the first position. Second position, axis parallel to HP and perpendicular to VP. This is the axis parallel to HP and perpendicular to VP. Position of the solid is like this. Cylinder, this is the one I taken only one example here. Cylinder. The cylinder axis is perpendicular to VP here, parallel to HP, horizontal plane parallel. When the solid position is like this, we should draw the first front view, because in the front view itself the base is visible. Okay, the front view is circle, and top view, when we look from this side, top view is a rectangle. Cylinder looks like a rectangle. First of all, draw the front view, which is above XY line, and project the point from that circle. We will get the rectangle in the top view. Okay, this is the top view of the cylinder. This is the front view of the cylinder when the axis of the cylinder is parallel to HP and perpendicular to VP. Third position, axis parallel to both the HP and VP. When the axis parallel to both the HP and VP, when the front view, then when we're looking from this side, the front view is a rectangle. When looking from the top side, the top view is also rectangle. Okay, so front view is a rectangle above XY line, and top view is also rectangle. Cylinder looks like a rectangle in both the views, front view and top view, when the axis of the cylinder is parallel to HP and VP, both the planes. Coming to the next position, axis inclined to HP and parallel to VP. Axis inclined to HP and parallel to VP. So axis is like this, inclined to HP and parallel to VP, vertical plane ki parallel ga untundi. Okay, ee position lo unnappudu how to draw the solid in the plane of paper. We should draw the solid in the plane of paper in two stages. After two stages, we will get the front view of the solid is like this, and top view of the solid is like this. Okay, this should draw in two stages. We cannot draw this solid in this position in single stage. Okay, whenever the solid axis is inclined to one of the plane, in the initial position, the axis of that solid placed perpendicular to that plane. Okay, here the axis is inclined to HP is given. So in the initial position, the axis must be placed perpendicular to the HP. That draw the initial position. After that, the axis will be rotated, whatever the inclination is given in the problem. After rotating the axis, we will get these two shapes, these two views. This is the front view and this is the top view. This angle makes an angle, some angle with XY line or with HP. Okay, the axis is inclined to VP and parallel to HP. This position, axis is inclined to VP and parallel to HP. Okay, in this position, the axis is inclined to VP means, first of all, the rectangle is look like in the top view, which the axis of this rectangle is inclined to XY line, and the front view looks like this. Okay, the solid is visible like this in the front view after rotating the axis with XY line. Okay, this is the second position, but initial position, we should assume that axis must be perpendicular to the vertical plane. Okay, okay, axis vertical plane inclined ga iste, initial position lo kuda axis perpendicular to VP anukoni draw cheyali. Axis inclined to HP ani iste, axis initial position lo perpendicular to HP and draw chestam. As in the case of projection of planes 2, in the planes 2, we assumed that whenever the surface inclination is given for the particular plane, we must assume in the initial position the surface is parallel to that plane. Okay, in that case, in parallel projection of planes 2, surface అనేది మనం ఇనిషియల్ గా ప్యారలల్ గా అనుకొని డ్రా చేస్తాం. ఇనిషియల్ పొజిషన్ లో ఏ ప్లేన్ కి అయితే ఇంక్లినేషన్ ఇచ్చారో సర్ఫేస్, ఆ ప్లేన్ కి ప్యారలల్ గా ప్లేస్ చేసుకొని డ్రా చేసుకుంటాం. ఓకే, బట్ ఇన్ సాలిడ్స్ ఏ ప్లేన్ కి అయితే ఇంక్లైన్డ్ గా ఇచ్చారో యాక్సిస్ ని, ఆ యాక్సిస్ ని పర్పెండిక్యులర్ గా పెడతాం. అదే ప్లేన్ కి పర్పెండిక్యులర్ గా పెట్టేసి ఇనిషియల్ పొజిషన్ డ్రా చేసుకుంటాం. ఓకే, దెన్ వీ కెన్ ప్రొసీడ్ ఇంటూ ద సెకండ్ స్టేజ్. So in the second stage, the views are like this. These are the two second stage views. Okay, and the last is axis is inclined to both HP and VP. Axis రెండింటికి inclined గా ఉన్నప్పుడు The solid of the front view is like this and top view is like this. Okay, axis is inclined to HP above XY line front view, and axis is inclined to VP, which is represented below XY line. Okay, these are the different positions we are going to draw in the solid projection of solids 1. In projection of solids 1, we are going to draw only prisms and cylinder. Okay, not pyramids and cone. Pyramids and cone is under the projection of solids 2 we are going to draw. Okay, let us go for the problem. This is the first problem. Draw the projections of a cylinder of base diameter 40 mm. First of all, you have to draw the cylinder in different position. Draw the projection of cylinder. Base diameter is 40 is given, and axis length is 70 long. Axis length is 70 long. Listen carefully. This is the first problem in the solids 1. When it is lying on a base point on the HP, the solid is lying on the HP on a base point, with its axis is inclined to 40 degrees to the HP. The axis inclination here, we have to give the first preference to the axis inclination. Here, axis inclination is 40 degrees to the HP. HP horizontal plane to 40 degrees to chestnut. So in the initial position, we have to draw the solid vertically, that is the perpendicular to HP. We have to place the solid axis is perpendicular to HP in the initial position. Whenever we place the perpendicular to HP, axis perpendicular to HP cylinder, the top view is circle, front view is rectangle. Okay, top view is circle. We have to draw the first top view, because the base is visible from the top side whenever the axis of the cylinder is perpendicular to horizontal plane. Okay, let us draw the first problem. Draw the XY line like this. Locate the XY points and draw the perpendicular line. In this solid position, whatever the point given in the problem, that point must be on the right side of the initial position. Initial position is like here. The right side of the initial position must be placed at that point. Okay, that point or edge, whatever it is, you must place on the right side of the initial position. Draw the perpendicular line. Locate any point. Draw the horizontal line that is parallel to XY line, and draw the perpendicular to the horizontal line. Here we are going to draw the circle first of all, because it looks like a circle from the top side in the initial position. So this line length and this line horizontal line length must be equal to 40, because circle diameter is 40. With this point as a center, draw a circle with 20 radius. Okay, this is circle. With this center 20 radius తీసుకొని ఈ circle draw చేద్దాం. Okay, ఈ circle లో ఈ point మీద మనం rotate చేయాలి కాబట్టి this point must be on the right side of the circle. That's why I am going to draw a perpendicular line for initially. Okay, in the planes లో అయితే whatever the point given in the problem, that must be placed on the left side of the extreme left side of the diagram. Here in the solids, right side of the initial position, you have to locate that point, whatever the point which is given in the problem. Okay, after getting this circle, divide this circle into number of equal parts like this. You have to divide this circle into number of equal parts. The total, I divided the circle into 8 equal parts. Okay, how to divide this circle into 8 equal parts? This is the 45 degrees. For every 45 degrees, you have to draw the lines within the circle. Those lines must be thin and circle only the thick line. Okay, after getting the points on the circle, base circle, locate the point like this. A1 of 1, 1, this point. From this point, you have to start the naming. A1 of 1, 1 means cylinder having the two bases. One is visible base. When we looking from the top side of the cylinder, the top base is visible base and bottom base is invisible base. Okay, the bottom base is naming as with the numbers and the top base is naming with lettering. Okay, letterings are visible, numberings are invisible. Bottom base is invisible. Clear, students? I will go for the another previous like this previous one. This is the cylinder. When with the perpendicular to HP, the axis is perpendicular to HP, this base is visible base and this base is invisible base. Okay, this base point, the top base points are visible points and bottom base points are invisible points. The bottom base points are located with letter numbering, and top base points with noted as lettering. Okay, these are the lettering base, numbering base. Numbering base is invisible. That's why we are placing within the bracket. Okay, divide this circle, and this is the A1 of B1, means A is the lettering base, upper base is visible base, 1 is for first stage. Okay, in the initial position, 1 that means numbering base, that is the bottom base in the first stage, bottom base corner, that is the bottom base point, and proceed those points on the circle. B1 of 2 1, B1 is a visible base, a visible point, and 2 1 is the invisible point on the bottom base. C1 of 3 1, D1 of 4 1, E1 of 5 1, F1 of 6 1, and G1 of 7 1, H1 of 8 1. Total 8 points. We will get 8 points. Out of those 8 points are upper base points, that is the lettering points, A1, B1, C1, D1 up to H1, and 1 1, 2 1, 3 1 up to 8 1 are the bottom base points. Okay, those numbering points are invisible. Okay, after getting these points, you have to project each point onto the XY line. This is the diameter of the circle is given as 40. 540 is diameter is 40. Like this, you have to give the dimensions and project the point. This is the top view of the cylinder when we're looking from the top side, when the axis is perpendicular to HP. Then draw the projection lines from A1 of 1 1, B1 of 2 1. Draw the projection lines. These 2 points are coincide with each other when we draw the projectors. And draw the projection from D1 of 4 1 with these 2 points are coincide with each other. Then draw the projection from the E1 of 5 1. Okay, we will get these 5 points on the XY line. This is the bottom base. Bottom base is numbering base 1 1 dash, and draw the straight edge which are connected to the upper base. Upper base and bottom base connected lines are straight edges. Okay, the upper base point is A1 dash, corresponding point is A1 dash. It is this 1 1 dash. Dash means it's a front view in the first stage. This is the lettering base. This is the numbering point. The numbering, this is the lettering. Okay, and locate this point as this point. How to locate this point? In this numbering base, 8 1 is visible, 2 1 is invisible. Okay, so 8 1 dash of 2 1 dash like this, like that you have to locate 8 1 dash of 2 1 dash. In this, 8 1 is the visible, 2 1 dash is the invisible point when we're looking from the front side of the solid. And this point is 7 1 dash of 3 1 dash, because 7 1 here, 3 1 is here. When looking from this side, 7 1 is visible, 3 1 is invisible. Next, coming to the 6 1 dash of 4 1 dash. Last one is 5 1 dash. This is the bottom base points which are numbering. Okay, this is the base, cylinder base. Cylinder looks like a rectangle in the front view. And draw the perpendicular to the base which are at a distance. This how much their length it is? Length is axis length. Axis length is given as 70 mm long. So you should draw the lines from 1 1 dash and 5 1 dash at a distance 40 mm to a distance of 70 mm. So it must be 70 mm. Locate these points and draw the top base. This is the top base. Cylinders top base, this one is looks like a line, and bottom base is also looks like a line. These are the 2 generators, extreme generators. Project the points like this. This is the axis line. This axis line located like this. One long and short line, combination of one long and short line is called the axis line, cylinder axis. Okay, look at the top base points. Top base points is this is A1 dash, and H1, B1 is there on this projector. H1 is visible, B1 is invisible. That's why H1 dash of B1 dash. This is the G1 is visible from this side, and C1 is invisible. G1 dash of C1 dash. Then F1 is a visible point, D1 is invisible. When we're looking from this side, F1 dash of D1 dash, last point is E1 dash. These are the topmost base points. Lettering, these are the numbering. Clear, students? This is the cylinder when looking from the front side. It is looking as, is visible as a rectangle. Cylinders looks as a rectangle. Give the dimensions of the rectangle, that is the axis length is given as 70 mm. So look at this is 70. Height of the cylinder is 70. This is the front view of the cylinder. Two views are possible whenever the axis is perpendicular to HP. ఇక్కడ యాక్సిస్ ఇంక్లైన్ టు హెచ్పి ఇచ్చారు. మనం ఇనిషియల్ పొజిషన్ లో యాక్సిస్ పర్పెండిక్యులర్ టు హెచ్పి అజ్యూమ్ చేసుకొని ఈ వ్యూస్ డ్రా చేశాం. ఇప్పుడు యాక్సిస్ ఏ పొజిషన్ లో ఉంది? ఇక్కడ యాక్సిస్ ఈజ్ పర్పెండిక్యులర్ టు XY. ఓకే, ఇక సెకండ్ పొజిషన్ లో యాక్సిస్ ఎంత రొటేట్ అవ్వాలి? 40 degrees టు హెచ్పి, అంటే 40 degrees టు XY రొటేట్ అవ్వాలి. ఓకే, బేస్డ్ అపాన్ దిస్ పాయింట్, ఈ పాయింట్ తో రొటేట్ అవ్వాలి. అంటే ఈ పాయింట్ అనేది ఎక్కడ ఉండాలి? ఆన్ ద XY లైన్. One of the base point when it is lying on a base point on the HP. So one base point is must be on the XY line. Draw the axis line. Okay, this is the axis line. And the angle is the 40 degrees. Then 40 degrees line. This is the 40 axis line. Then draw the bottom base. First draw the bottom base. This is the bottom base, which is perpendicular to the axis line. Axis line ki the perpendicular ga untundi base. So you have to draw the base such a way that the one of the base point is on XY line. You have to draw like this. The axis of the solid is must be 40 degrees. At the same time, base one of the base point is on XY line. So look at one of the base point on XY line. Like that, you have to draw the base. From the axis, half of the base is on one side and half of the base is on another side. Clear? After drawing the base, draw the straight edges, longer edges. If these are the longer edges, we are rotating this solid into 40 degrees in the second stage. Okay, like this, you have to rotate the whole solid. You have to rotate 40 degrees with this point, with respect to this point. This point must be on the XY line. This point is 1 1 dash. Here 1 1 dash becomes 1 dash here. Okay, and remaining lines are, this is the line which is a distance which is equal to this distance. Draw the line, a thin line which is equal to this distance, and another thin line which is equal to the distance from the outer edge, and locate the points on the base. This is the 1 dash. This is the first stage point, and this is the final stage. Second stage is the final stage here. 1 dash. And remaining 8 1 dash of 2 1 dash becomes 8 dash of 2 dash here. Like that, you have to remove the suffix 1. This is the first stage, that's why we are locating 1. If this is the last stage, we have to remove that 1 suffix 1. 7 dash of 3 dash is the axis line, on the axis line. This is the 6 dash of 4 dash, and this is the 5 dash. Okay, the corresponding lettering points are, this is the A dash. This is the A1 dash becomes A dash. Next point is H1 dash of B1 dash is becomes H dash of B dash. And next point is G dash of C dash, this point. And this point, base point is F dash of D dash, here F1 dash of D1 dash. And last corner point is E dash. These are the lettering base points. These are the numbering base points. After getting these points, you have to draw the projectors from each. This is the front view after rotating. Axis is inclined to 40 degrees to the HP. This is the front view. Okay, after getting the points, each point, draw the projector lines. That is the vertical projection lines from each point. That is the these are the projectors from the upper base, and draw the projectors from the bottom base points. These are the bottom base points. Like this, you have to draw all the vertical projectors from each point, upper base points and bottom base point. Clear? Then draw the horizontal projectors from these 8 points. Draw the horizontal projector from A1 of 1 1, which is coincide with the E1 of 5 1, and draw the horizontal projector from B1 of 2 1, which is coincide with the D1 of 4 1, and draw the projector from C1 of 3, 1 horizontal projectors. Like that, you have to draw the horizontal projectors like this from each point of the top view, first stage top view. After getting these points, the intersection point, you have to locate the upper base points and bottom base points. How to locate the points? First of all, we go for upper base point. How to locate the upper base point? Starting from A, the line which is coming from the A dash intersect the line coming from A1. This point is A. This point is intersection point is A. Okay. And then how to get the P point? The B is the point of intersection between the line B dash line and B1 line. Okay. Next, C is the point of intersection between C dash line and C1 line. This is the point. Then D is the point of intersection between D dash line and D1 line. This is the point. Next, E point is intersection point between E dash line and E1 line. The corresponding point is E. Next point is the point EF. F is the next point. F is the point of intersection between the F dash line and F1 line. This is the point. Then G point, G dash line intersect with the G1 point. G1 here, G1 line, the located as G point. And lastly, H, the line which is intersecting the H dash line intersecting with H1 line. This is the H1 line. This point is the H. Okay, we will get this is the upper base point, which looks like an ellipse from the top side. Okay, whenever the axis rotates like this, which looks like an ellipse. Then coming to the bottom base. Bottom base is numbering. Similar to upper base, you look at the bottom base. That means the line of point of intersection between 1 dash and 1, 1, this point is 1. And point of intersection between 2 dash and 2, 1, this is the 2. Here without dashes, we have to locate the top view. And 3 point here, 3 dash line intersecting 3, 1 line. And 4 point is 4 dash in the line intersecting 4, 1 line is the 4. And 5 point is the line of intersection of 5 dash with 5, 1 line. And 6 point is yet 6 dash line intersecting with the 6, 1 line. And the 7 point is 7 dash line which is coming from the front view, which intersecting the line coming from the 7, 1. This is the 7. And 8 point is will get the line of intersection, the point of intersection between 8 dash line and 8, 1 line. This is the 8 point. Like that, you have to locate the bottom base points and upper base point. After getting these points, you have to draw the outer points first. Okay, outer point is C, A, B, C, and 3, 4, 5, 6, 7, G, H, A. Like that, you have to draw the first outer line. This is the visible base, and draw the outer line. This is the outer line. This is the outer curve. Okay, na? This is the outer curve. This is the visible base. When we're looking from the top side, this is the visible base. That's why we are draw totally fully the ellipse. And when we're looking from the top side, the bottom base is off of the bottom base is visible. That is from 7 dash to 7 to 3, and remaining 1, 2, 3 and 1, 8, 7 are invisible. This curve is invisible from when looking from the top side. That's why we are drawing a dotted line. Okay, this is the invisible curve. Bottom base lo oka half matrame visible, remaining of invisible dotted line. But upper base matram mottam kanabadutundi kabatti full ga dark line to draw chestam. At the same time, this is the outer lines which are connected to bases of the cylinder. Okay, this is the view after rotating the axis with XY 40 degrees. This is the top view. Yes, students, I hope you are understanding. When the two views, these two views will get, that means axis is inclined to HP. Whenever the axis is inclined to HP, these two views are formed. Whenever the axis is perpendicular to HP, these two views are formed. But in the problem, asked that with the axis is inclined 40 degrees. So 40 degrees, these two views are final views, front view and top view. If you want to if you want to get these two views, you have to draw the first views first. Okay, without these two views, we cannot draw these two views because we don't know the shape of the sizes of this rectangle in the initially. Then if we draw the first stage only, then only we can draw the second stage. Okay, like this, you have to draw the cylinder position in different. That's the axis is inclined to HP. Okay, then next problem. Let us go for this problem. Draw the projections of an equilateral triangular prism of base side 40. Is a prism. We are going to triangular prism. Base side is 40 and axis 70 long. Base side istadu, axis length istadu, and the axis position kuda istadu. When it is resting on an edge of its base, oka base edge meeda rest ayundi HP meeda. Okay, the face containing that edge makes an angle of 40 degrees with HP. Okay, ఏ ఫేస్ అయితే ఎడ్జ్ అయితే హెచ్పి మీద రెస్ట్ అయిందో ఆ ఎడ్జ్ తో పాస్ అయ్యే ఫేస్ రెక్టాంగులర్ ఫేస్ ఉంటుంది కదా, ఆ రెక్టాంగులర్ ఫేస్ అనేది ఇంక్లైన్డ్ గా ఉండాలి, 40 degrees to the HP ఇంక్లైన్డ్ గా ఉండాలి. Okay, let us draw the problem. There is a diagram. Draw the XY line first and draw the perpendicular line as it is. That is the perpendicular line. On that perpendicular line represents the line which is equal to the this is the base edge, triangular base edge, which is equal to the 40 mm. Okay, and draw another line which is makes an angle of 60 with base edge. This is the 60 degrees and length is 40. Draw the another line from this point. This is the 60 degrees angle and length is 40. So like this, you have to form a triangular base, because the face containing that edge means axis. Indirectly, the axis is inclined to HP. Whenever the axis is inclined to HP, in the initial position, the axis assumed to be perpendicular to HP. Whenever the perpendicular to HP axis, when we looking from the top side, it is visible as a triangle. Okay, first of all, you have to draw the top view here. Axis perpendicular to HP, axis inclined to HP ఇచ్చినప్పుడు top view draw చేయాలి. Axis inclined to VP ఇస్తే front view draw చేయాలి first. Okay, ఇక్కడ inclined to HP ఇచ్చారు కాబట్టి ఫస్ట్ టాప్ వ్యూ డ్రా చేశాం. ఓకే, టాప్ వ్యూ ఎలా డ్రా చేయాలి? ఎడ్జ్ అని రిప్రజెంట్ చేస్తున్నప్పుడు ఆ ఎడ్జ్ అనేది ఒక పర్పెండిక్యులర్ లైన్ డ్రా చేసుకొని ఆ పర్పెండిక్యులర్ లైన్ మీద రిప్రజెంట్ చేస్తాం ఎడ్జ్. By using that edge, based on that edge, you have to construct a triangle, equilateral triangle. Okay. The triangle naming is corner names are A1 of 1 1. Previously, I said that. What is A1? What is 1 1? A is the lettering naming for the top base point, and 1 numbering is for the top bottom base point. Okay. One suffix 1 is in first stage. A1 is visible point and 1 1 is invisible corner of the triangle. Okay. Next, B1 of 2 1, C1 of 3 1. Every corner represents 2 points. Those 2 points related to upper base and bottom base. Clear? After getting these 3 points, locate the center of the triangle. How to locate the center of the triangle? Join the apex point, that is the one corner with opposite midpoint. Opposite midpoint to then join cheste oka line vastundi. Like that, you have to draw another line. This corner with opposite midpoint, opposite side midpoint. That intersection of these two lines is the center of the equilateral triangle. Okay, this is the geometric center of the triangle. From the triangle, you have to draw the projection line. And draw the projection line from C1 of 3 1. Like that, from each point in the top view, you have to draw the projection line. Okay. This is the bottom base. By joining those 3 points, we will get the bottom base, a thick line. Okay. Triangular prism is also looks like a rectangle in the front view. This is the axis line. This is the axis point. This is the axis line, which is drawn with one long and short combination line. Okay, this is the axis line must be drawn like this. Then one straight edge, another straight edge from the C1 dash or C1 of 3 1, and join those two straight edges with the top base. This is the top base, which looks like a straight line. Bottom base is also looks like a straight line in the front view. These are the edges, straight edges, which are connected, the top and bottom bases. Okay. After getting the rectangle in the front view, locate the points. This corner, 4 corners represent cheyandi. A corners ela represent chestaru. This is the bottom base kabatti bottom base is the numbering. Okay. When we're looking from when we're looking this diagram from this side, bottom base low 2 1 is visible, 1 1 is invisible. ఓకే, ఇక్కడ నుండి చూసినప్పుడు 2 1 కనబడుతుంది, 1 1 కనబడదు కాబట్టి ఈ కార్నర్ ని 2 1 డాష్ ఆఫ్ 1 1 డాష్ గా రిప్రజెంట్ చేస్తాం. Dash is the front view. And next point is, this point is 3 1 dash. This point is 3 1 dash. Only one point is there. Another point, C point, is related to upper base. Okay. And next point, this point is from this side. When we look from this side, B1 is visible, A1 is invisible. So B1 dash of A1 dash is the point of upper base, and this point is C1 dash. Like that, you have to locate the points on the front view. The first stage, this is the initial position when the axis is perpendicular to XY line. When the axis is perpendicular to HP, or the triangular face, the rectangular face, that edge containing this edge ki sambandhinchina face idi. ఇక్కడ 4 పాయింట్లు ఉన్నాయి చూడండి, ఇక్కడ 2 పాయింట్లు, ఇక్కడ 2 పాయింట్లు. ఈ 4 పాయింట్లు ఏంటంటే ఒక ఫేస్ ని ఫామ్ చేస్తాయి. ఈ ఫేస్ అనేది ఇనిషియల్ గా XY లైన్ కి పర్పెండిక్యులర్ గా డ్రా చేసాం. బట్ ఈ ఫేస్ అనేది ఎలా ఉండాలి? 40 degrees టు HP ఉండాలి. అంటే ఈ లైన్ 40 degrees రొటేట్ చేయాలి నెక్స్ట్ స్టేజ్ లో. ఇనిషియల్లీ ఇది పర్పెండిక్యులర్ గా ఉంది. ఓకే, give the dimension of triangular base 40 given, and the height of the axis length is 75. Okay, axis length is 75. This is the front view diagram. This is the top view diagram. These two views will be get like this when axis is perpendicular to HP. Axis perpendicular to HP unnappude ee two views possible. Okay, అర్థమవుతుందా? ఇంకా నెక్స్ట్ స్టేజ్ లో ఏం చేస్తాం? నెక్స్ట్ స్టేజ్ లో ఈ లైన్, దిస్ లైన్ రిప్రజెంట్స్ ఎ ఫేస్ ఆఫ్ ట్రయాంగులర్ ప్రిజం. ఈ ఫేస్ అనేది ఎలా ఉండాలి? 40 degrees రొటేట్ అవ్వాలి. ఓకే, like that's why you have to locate this point on the XY line. First of all, 2 1 dash of 1 1 dash becomes 2 dash of 1 dash, because 1 is first stage, next stage is last stage. That's why I am removing the suffix 1. Locating somewhere else one point which is located as 2 dash of 1 dash. From the 2 dash of 1 dash, draw an inclined line. Okay, that inclined line having the angle 40 degrees. Okay, from this 2 1 dash of 1 1 dash, draw a straight edge. This is the straight edge. How much is straight edge length? That is 75 mm. From this, draw the 75 mm thick line. Okay, on that inclined line, and draw that perpendicular to that straight edge. Perpendicular to that straight edge, this base length is equal to this base length. That means from 3 1 dash to 2 1 dash of 1 1 dash length, you have to draw the base, bottom base. That is the 3 dash. This 3 1 dash becomes 3 dash. From that, this is the B dash of A dash. This is the B1 dash of A1 dash is becomes B dash of A dash. From 3 dash, draw the another straight edge. That is the longer edge, which is equal to 75 mm long. And finally, join these 2 points. This is the top base. Top base. Initially, top base is parallel to XY. After rotating, the top base is 50 degrees, which makes 50 degrees. This line makes 40 degrees. So this point is C dash. Locate this point as C dash. This is the axis line. This is the C dash. Axis line, which is at a distance nearer to the this face. This face ki దగ్గరలో ఉంటుంది axis point, axis line. Okay. After getting these points in the front view, draw the projection lines from each point. This is the upper base points projectors. Similarly, draw the projector from the bottom base points. Okay, vertical projections, and draw the horizontal projections from this diagram. The horizontal projections from 3 corners. Okay, then first draw the upper base, locate the upper base point, that is the lettering points. How to draw how to locate the points? the intersection point of intersection between A dash line and A1 line, this intersection point is located as A. This point is A. Okay. Then the line which is coming from the B dash intersecting with the B1, this point is B. And next, the C point is C dash line intersecting with C1, this point is C. Similarly, bottom base points, this point is 1, this point is 2, this point is 3. Okay, these are the points. First, to draw join outer points. Outer points are A, 1, 3, 2, B, and A. Like that, you have to draw the outer, join the outer points. AB, A1, 1, 3, 3, 2, and 2B. Like this, you have to draw join outer points first. In any solid, you have to join outer points. After outer point joining, then draw the bases. 2 bases are there for a triangular prism. Out of these 2 bases, which base is visible base? When we looking from this side, this total base, lettering base is visible base. This numbering base, some of the numbering base is invisible. Okay, so visible base is must be dark line. So draw the lettering base is dark line AC, join AC and join the B with C. This is the visible base when looking from the top side. Okay, and also the C dash 3 dash longer edge is also visible. So that's why I'm joining 3C here. Clear? This is the longer edge, A1, A to 1 longer edge, B to 2 longer edge, C to 3 is also longer edge. 3 are visible from the top side. Only unknown, only one base edge is invisible. That is line joining 1 and 2. 1 and 2 line joining is invisible. That's why I am joining this 1 and 2 with a dotted line. This is the only baseline is invisible when the solid is in this position. Okay. So this is the front view after rotating, the face rotating with 40 degrees with XY. And this is the top view. Final stage front view, final stage top view. These are the only 2 stages in these solids. These positions, these 2 views are getting when the axis is inclined to HP. The axis is inclined to HP. This line is parallel to XY axis line. So the axis also makes an angle 40 degrees with XY. Clear, students? This is the problem. This is the problem related to the triangular prism. Prism means 2 bases. Clear, students? In the next class, I will explain remaining problems. That is hexagonal and pentagonal prism. Then we will go for pyramids. Okay, I'm closing this class today. Bye. Have a nice day.